small m by 2r. Escape velocity. As the name suggests, to escape, what should be the velocity and what is the velocity? The escape velocity on Earth is the minimum velocity with which a body has to be projected vertically upwards from the Earth's surface so that it just crosses the Earth gravitational field and never returns. This means that Earth is here. Say it has some gravitational field. Now with what minimum velocity, least velocity, a body has to be projected vertically upwards so it crosses this gravitational field and it never returns back. So this escape velocity of any object is given by V sub e under root 2 g capital M by capital R. This is under root 2 gr, which can be expressed in this expression also. So the escape velocity, it doesn't depend on the mass or shape or size as you see in the expression. Not even because the direction of projection of the body is also not important. So escape velocity at Earth is 11.2 km per second. There are some important escape velocity you must know. For Moon it is 2.3 km per second, Mercury 4.28, Earth, as I said, 11.2 km per second, Jupiter 60 km per second, Sun 618 km per second, neutron star 2 into 10 to the power 5 km per second. So what is the relationship between V escape, that is escape velocity, and orbital velocity? The escape velocity is equal to under root 2 times the VO, that is orbital velocity. So if the velocity of projection is equal to the escape velocity, that is V equal to VE, then the satellite will escape away from the Earth using, or from the planet using a parabolic path. And if velocity of projection of satellite is greater than the escape velocity, that is V is greater than VE, we just have known V when it is equal to VE. When it is greater than VE, then the satellite will escape away following a hyperbolic path.